Hello everyone, I am Balraj Govindaraj, QA architect and IT specialist expert. Today I am like to explore how codeless automation and AI prompts empower manual testers. I'm going to take around 20 minutes and I'll be discussing about the challenges, the automation barriers and a new paradigm, how to democratize automation and the frameworks that we follow to implement those automation, codeless automation and the benefits. And we will also discuss about the common concerns and the takeaways at the end before closing. Okay, let's get started. From manual testing to prompt to mastery, how this can be achievable? Yes, this is achievable. This is very beneficiary, I would say. But the first challenge facing, we need to discuss about the challenges for the manual testers today. There is a widening gap. Job posting now demand automation and AI skills, creating a sharp divide in QA. Manual testers, though rich in product knowledge and domain expertise, face growing pressure as roles evolve faster than ever. Script-based tools like Selenium and Cypress remain out of reach for many non-coders, widening gaps in pay, progression, and job security. The rising stakes? Yes, AI-driven development and rapid CI/CD cycles have raised the bar for quality assurance. Teams are now expected to deliver faster feedback, broader coverage, and continuous integration of tests into every build. The risk? Yes, seasoned testers with invaluable insight into user journeys are being sidelined by technical automation roles, even though their intuition remains irreplaceable. With traditional automation barriers, coding prerequisites. Automation tools demand coding skills like Java, Python, JavaScript that many experienced manual testers lack. This technical barrier creates an artificial divide between technical and non-technical testers and understanding the complex frameworks. Now the complex frameworks shift focus from what to test to how to code the test. This distracting from core quality insight. And another burden is maintenance. Script-based automation requires constant updates for all UI chain, creating significant technical debt that buries team in maintenance work rather than innovation. A new paradigm, democratizing the test automation. The convergence of codeless automation platforms and prompt engineering techniques offers a transformative solution. By combining intuitive visual interfaces with well-crafted AI prompts, organizations can empower manual testers to translate their domain expertise into executable tests without writing a single line of code. Visual simplicity. Codeless platform use drag and drop interfaces that mirror testers' mental models, making automation accessible and intuitive from day one. And next one is prompt engineering that unlocks sophisticated test generation, self-healing locators, intelligent assertions through natural language commands. If we're able to handle these two, we can able to preserve the domain expertises. Testers leverage their irreplaceable product knowledge while seamlessly adopting modern automation practices and contributing immediately. 4-phase transformation framework. Platform evolution, knowledge transfer, standardization the process, and scaling the process. In platform evolution, initially we need to access codeless tools based off organization needs, tech stacks compatibility, and AI prompt engineering capabilities. Look for the platforms that truly democratize the automation. This is very important to take around. And once we have a curated platforms that were set, then knowledge transfer. Train manual testers on visual automation and the prompt engineering techniques, avoiding technical complexity while building confidence through hands-on practices. That way, testers will be ready to work on the day one. Standardization process. Establish the reusable prompt libraries, test templates, and the best practices for consistency. Create a foundation for scalable, maintainable automation. Then scaling up the process. Integrate the automated tests into CI/CD pipelines, expand coverage systematically, and measure impact on release velocity and defect detection rates. Let's detail about phase one, evaluating the codeless platforms. There are critical selection criteria that we need to take care of. That way, rest all four three phases will be in the smooth place. First thing is AI native features, the tools that should support prompt engineering capabilities and intelligent test generation. Visual workflow design, the tool that should intuitive builders that mirror testing thought processes. Then seamless integration, connects to Jira, CI/CD tools, test management tools. Nowadays, all the tools support this. So I think we should be good in this. Self-healing capabilities, adapts automatically to UI changes, dramatically reducing maintenance burden. That's upcoming. Even for the code, we were expecting the self-healing capabilities to reduce the maintenance. Then why not? It is with codeless automation. Collaboration tools, version control, team libraries, and shared resources. These things we should tools that support all these activities. We need to avoid platforms that merely hide code behind abstractions or require extensive scripting for advanced scenarios. True codeless solution should enable productivity in days, not months. Some of the example I like to explain about the phase one that I discussed about. A financial service QA team used Testium autonomous mode to auto-generate one-to-day login and a dashboard test from plain English prompts in a week. The key takeaways: AI-driven test creation saves manual scripting time and uncovers missed edge cases yearly. Second example, the visual workflows that I was talking about earlier. A telecom tester adopted test rigors recorded to build the regression flows by clicking through the UI. No export editing needed. Key takeaway: visual builders mirror a test mental model, allowing manual testers to contribute automation immediately. Phase 2, knowledge transfer and upskilling. Reframe the automation concepts. Introduce visual workflows as a natural extension of manual test cases rather than fundamentally different disciplines. Map a familiar testing terminology to automation constructs. Introduce prompt engineering basics. Teach testers to write effective prompts that generate accurate locators, assertions, test logic. Start with simple examples before progressing to complex scenarios. Early win, right? That makes us to feel better on contributing each thing. Hands-on practice. Provide a sandbox environments where testers can environment safely without fear of breaking production systems. Encourage iterative refinement and peer learning. Now all the software systems have their own dedicated test environment. That is the best place to practice whatever they like. Because beyond that, there are stage, UAT, performance platforms, everything is different. So nowadays, all applications have a standard test environments to practice with. Celebrate the early wins. Recognize initial automation success publicly to build momentum. Showcase how quickly manual testers can contribute meaningful automated coverage. That makes feel better even for other testers. Okay, that's something they feel that something that is doable and they're able to move forward with it. The special mention about the prompt engineering, that is a boom. The bridge to automation. Prompt engineering bridges the gap to AI-powered automation, letting testers use natural language to articulate testing intent, the skill they have already honed from years of writing test cases and bug reports. For example, natural language test. Navigate to checkout, verify total matches cart, complete payment with valid card details. It's a pure natural language, but it's a prompt for the one trigger or one command. How to locate the locators with a natural language. Simple, in a simple word. Find the submit button in the login form, even if it is ID or class name, changes between releases. That way, it automatically detects the submit button, even if it is an ID form or class form. This will take care of it. And how to implement the assertions in the command. Confirm error message appears when email format is invalid and includes helpful guidance. This is a simple language that act as a command for the assertions navigation. Effective prompts reduce complexity dramatically, allowing testers to focus on what needs testing rather than wrestling with how to code it. This leverages existing domain expertise instead of requiring entirely new technical skills. Because new technical skill paper lack on the domain knowledge. So that's sometimes it is risky. Some of the examples I like to describe about it. Reframing automation concepts. A government QA team converted 50 manual UI flows into visual workflows using test rigor and ChatGPT prompts. Instead of saying click here, validate there, testers started saying verify user registration email triggers after successful form submission. This is the natural language act as a command. These plain language steps auto-generated codeless automation scripts. The key benefits, testers finally saw automation as a storytelling, not a coding. Tech prompt writing. One example on it. During a 2-week workshop, testers practiced transforming acceptance criteria into AI prompts such as login with valid credentials. Check the dashboard loads within 2 seconds. This is a command test that will evolve it. Tools like Marble and Testing converted those into maintainable automated tests. Key benefits builds confidence that language is equal to logic. Nothing to think more about it. Once testers realize their own words can power automation, confidence skyrockets and your transformation takes off. Phase 3, that is very important, standardizing and storing all the best practices. First, initially prompt libraries. Curate the proven prompts for common testing patterns like login flows, form validation, data verification, enabling quick reuse and adoption across projects. And also standardize the templates like test templates. Develop standardized frameworks for different test suite types like regression, smoke, integration, ensuring consistency while maintaining flexibility. Quality guidelines. Establish clear criteria for maintainable automation, naming conventions, documentation standards, and review process that prevent technical debt. Standardization accelerates onboarding for new team members, improves cross-team collaboration, and protects institutional knowledge from being lost to turnover or organizational changes. Where cohorts turns into clarity in the space 3. Prompt libraries. The state-level QA team created a centralized prompt library inside Confluence. It included reusable prompts for our login, payment, and data validation across 12 microservices. When any prompt was improved, all related test suites auto-updated via a linked references. Key benefits. Every tester contributes once and everyone benefits. Write once, test everywhere that is possible. Test templates. Some of the examples. Teams in different business units build standard templates for regression, smoke, and API test. A tester could clone a base API health check template, customize a few prompts, and be up and running in minutes. Key benefits. Maintains consistent coverage and structure across products while saving setup time. Phase 4, scaling and CI/CD integration. Pretty much, yeah. Scaling up the process is important part of all the 4 phases. Like CI/CD integration, embed codeless automation into continuous integration pipelines, configure automated test execution on code commits, pull request, and scheduled intervals for continuous quality feedback. Progressive coverage, expansion. Start with critical user journeys, then systematically expand to edge cases and integration scenarios. Measure coverage growth alongside defect reduction rates to demonstrate the value. Performance monitoring. Track key metrics, test execution time, flakiness rates, maintenance effort, and time to feedback. Use data-driven insights to refine the approaches and demonstrate clear ROI to stakeholders. Some of the example of it, like in CI/CD integration. In one of the insurance modernization project, automated test suites were triggered directly from GitHub Actions and assured DevOps pipeline after every code commit. Within 3 sprints, 80% of the regression checks ran automatically before UAT. Key benefits: QA become continuous. Defects are caught in hours, not in days. Progressive coverage expansion. The QA team began with 5 critical business flows like registration, payments, and reports. Over time, they used prompt-based test generation to expand coverage to 45 plus edge scenarios. Using dashboards, they tracked automation coverage growth alongside defect reduction trends. Key benefits: builds measurable momentum, expanding impact without overloading teams. Where the transformation becomes self-sustaining. We stop treating QA as a project base. It becomes part of the organization's DNA. Every release, every commit, every probe adds intelligence to the system. Key takeaways. Empowering manual testers. Transforms manual testers into automation enablers by equipping them with codeless platforms and AI-driven tools, leveraging their invaluable domain expertise. Structured transformation, a 4-phase framework guides organizations through platform evolution, skill development, standardization, and scaling for sustainable automation success. A prompt for prompt engineering. Prompt engineer act as the critical bridge, allowing testers to use natural language to define complex test logic and accelerate automation adoption. Enhanced quality and efficiency. This approach delivers faster release cycles, higher software quality, and empowers QA teams, ensuring they remain central to the development process. Transforming QA into a human-centered discipline. Human plus AI equal to smart quality. This framework doesn't replace human testers, it empowers them. By blending codeless automation with AI-driven prompts, testers amplify their impact without losing the creative and critical thinking that define real quality. The future of QA isn't just faster, it's more human, more insightful, and more collaborative. Measurable benefits of the transformation. These improvements translate directly to accelerated release cycles, reduced production defects, and enhanced team morale. Quality becomes shared responsibility rather than the bottleneck. Faster test creation. Codeless approaches dramatically reduce time from test design to execution. Coverage increase. The democratized automation enables broader test coverage across features and platforms. Maintenance reduction. Self-healing tests and AI-driven updates minimize ongoing overhead. Tester engagement. Manual testers report higher job satisfaction when empowered with automation skills. Safeguarding institutional knowledge. This is the key thing that we were introducing this framework. One of the greatest risks in traditional automation transformations is the loss of domain expertise. When manual testers are sidelined, organizations forfeit years of accumulated product knowledge, user behavior insights, and edge case awareness. So we capture the expertise, testers encode domain knowledge into reusable prompts and visual workflows, and share widely. Codeless platforms make automation assets transparent and accessible to entire teams. Evolved testers refine and expand automation based on production insights and emerging scenarios. This virtuous cycle transforms institutional knowledge from tribal wisdom into living documentation, resilient to team turnover and scalable across the organization. Some of the common concerns that I would like to address, pretty much everywhere in the social media, but I like to give the answer for that. Would AI replace testers entirely? No. AI augments human judgment, but cannot replicate the critical thinking, empathy, and contextual understanding that experienced testers bring. Codeless automation makes testers more valuable, not obsolete. Are codeless tools robust enough for complex scenarios? Modern platforms handle sophisticated workflows, including A/B testing, database, validation, and conditional logic prompt. Prompt engineering unlocks advanced capabilities without coding requirements. What about vendor lock-in? Choose platforms with export capabilities and open integrations. Prioritize tools that enhance rather than replace existing process, allowing gradual adoption and flexibility. Key takeaways. Democratize automation with codeless platform and follow the 4Ps framework. Leverage the prompt engineering as a bridge skill, then amplify the institutional knowledge. Thank you everyone for listening this. I hope this was very helpful for all the organizations that who are undergoing all the AI upgrades. Thank you.